All right, welcome back to Dart University Engine Building 101. We're actually going to step back a little bit and talk about manufacturing, because that's what really delivers the parts for you to start doing your build. Now, in the old days, you might get a salvage yard block or even a new block, and you think, well, I need to go in and deck it, I need to square everything up, I need to maybe do a line hone on the crank. Well, you don't have to do that on a Dart system. They put a lot of infrastructure, a lot of energy into buying state-of-the-art machining centers that can do real high-quality parts, so when you get yours, it's ready to go, and you know it's right in spec. Now, if you think about, something as large as maybe a big block or a big casting, you put it on a machine like this, a Bridgeport, just the mass alone set up on this table is going to have a lot of deflection just from mass. Now you add tool pressures, to make those cuts. You're going to get a lot of deflections. You're never going to be able to get the critical tolerances that you'd like. So these big machine centers, the fixture, just to hold the part, may be as big and heavy as this entire machine. That's going to give you better quality. It's going to let you hold those tolerances better. And these are all NC machines, 4 and 5 axis. They can do really amazing things from, right off a casting to an entire billet block. So if you're going to get started on your build, you've got a good piece, a good foundation to begin with. All along the process is Dart Machines, they're keeping records. They know exactly what that is. Now you're going to get an information packet with the generalities of your block, but if you need anything specific, like what's the lifter bore diameter, what's the diameter of my cup plug freeze, my freeze plug, they have everything. It's all tracked so you can get a hold of them and know exactly where your block started, even if it's years from now. So you're going to get a quality part to start with. Everything's going to be right in spec. The next thing to think about is interactions with other components. So I may have a tolerance range that I nail on this block. Let's say I'm on the high side and the crank's on the high side and your bearing shells are on the high side. I might have a tight bearing clearance. Same thing on the low side, I may have a big bearing clearance. So the idea is you got a good starting point here, but you still have to check those interactions. So the blueprinting idea is I know what my block is, I blueprint, I know what my crank is, I know what my bearings are. Now I can know all these important relationships, all my clearances, so I can build it right. All right, so those are all the pieces, right? Getting your quality part, getting all the other parts of the interactions so you can really put it together, make a high performance precision machine so you can go out there and hammer on and really have a good time.